When engine aircraft designers get it right, their creations can become legendary. However, history is littered with lost and extremely superb aircraft engines. So in today's video, we are going to show you aircraft engines that might be out of the future. First on our list is the engine from CFM International. GE Aviation and Safran have joined forces to form CFM International. It is responsible for the LEAP, dubbed the dominant narrow-body engine of the future, and the CFM56, the best-selling aircraft engine in history. Even though both of the engine families are more efficient than their predecessors in terms of fuel consumption and carbon dioxide emissions, their potential replacement is being hailed as the future of flight. In June 2021, CFM introduced its new RISE, Revolutionary Innovation for Sustainable Engines program. According to the company, this program will have produced the next generation CFM engines by the middle of the 2030s. The program's objective is to reduce fuel consumption and carbon emission by over 20%, and it will utilize both sustainable aviation fuel and hydrogen. The CEO of Safran, Olivier Andriès, stated in a video that the program would be a true game changer and write a new chapter in aviation technology. The RISE program's open fan architecture is its most important component. The executive manager of the system engineerings of the CFM RISE program, Delphine dijoud, described it as the most ambitious and the most useful portion of the plan. This will help optimize engine operations throughout the flight, explained dijoud. This will result in further efficiency gains and reduced emissions. Pratt Whitney produced the second engine on our list. Pratt Whitney is one of the largest manufacturers of engines for commercial, regional, and military aircrafts. On the commercial side, the PW1000G, which powers the Airbus A220 and the A320neo family, is most likely its most recognizable product. There are 6 distinct PW1000G variants. Since they all possess geared turbofans, they are also known as GTF family. More than 1,000 aircrafts are equipped with GTFs. Jeff Hunt, the company's senior vice president of engineering and technology, stated that it had invested $10 billion in its geared turbofan technology. Hunt stated to Flight Global, "We have established what I consider to be the benchmark architecture that provides us with the flexibility to adapt as the industry seeks to align with climate change." Fans in GTF engines rotate more slowly than the compressor and turbine. This gives them the highest bypass ratio in the industry, 12:1. According to the company, the geared turbofan design reduces fuel consumption, noise, and air pollution by double-digit percentages. According to Pratt Whitney, the fuel efficiency of its engines improved by about 1% annually. Christopher Callio, president of Pratt Whitney, stated at Raytheon's 2021 Investor Day that the GTF designs is the architecture of the future and that its efforts are being made to increase the bypass ratio even further. In addition to its commercial turbofans, Pratt Whitney is a significant supplier of regional turboprop engines. It collaborates with De Havilland Aircrafts of Canada to develop a hybrid electric turboprop demonstrator. The Dash 8-100 will serve as the basis for the joint ventures, and flight tests are anticipated to begin in 2024. According to Pratt & Whitney, the regional market will be one of the first segments to benefit from new, lower-carbon technologies such as all-electric, hybrid electric, and hydrogen-powered propulsions. However, the company also believes that regional turboprop improvements will eventually benefit larger-scale aircrafts as well. Next on our list is the engine from GE Aviation. In addition to the popular CFM56 and LEAP engines it makes with Safran as part of the CFM partnership, GE Aviation also gives commercial airlines several other turbofan engines. Its GE90 may be best known for being the first to use composite fan blades. It would also later become the first engine to incorporate an FAA-approved 3D printed part. Even the Museum of Modern Art in New York exhibited the blade's curved form as a perfect example of modern engineering, design, and beauty. When entered into service in 1995, the GE90 was the world's largest jet engine. By 2020, the GE90 engine that powers the Boeing 777 family will have logged more than 100 million flight hours. The GE9X employed similar technology to the GE90. According to the manufacturer, the GE9X redefined what was possible with innovative technologies that took fuel efficiency and propulsion to the next level. The GE9X consumes up to 15% less fuel than its predecessor and has the highest fuel efficiency in its thrust class. According to the company, this is the most solid high-thrust jet engine in history. The Boeing 787 and 747-8 are equipped with GE9X engines. The GE9X is the newest engine from GE Aviation. According to the manufacturer, it is the most fuel-efficient engine it has ever produced. The GE9X engine was designed for the Boeing 777X. It consumes 10% less fuel than the GE90 and emits fewer NOx than any other GE engine. The CF6 engine from GE Aviation is still used in many commercial aircraft, including the Airbus A330, Boeing 747 and 767, and the Boeing 747 and 767. The 5 variants of the CF6 have logged 115 million flights. Additionally, GE is developing a technology known as Mustang, more electric systems and technology for aircraft in the next generation, to provide more electric power systems. In addition to the RISE program, this is included. Other plans include developing lighter materials and better cooling methods, which will increase the efficiency of the engines. Finally, the last engine manufacturer on our list, Rolls-Royce. Rolls-Royce is best known for its high bypass turbofan Trent engines, which powers aircraft such as the Airbus A330, A330neo, and A380, as well as the Boeing 777 and 787. The British company announced earlier this year that it had begun manufacturing the UltraFan, the largest jet engine in the world. According to the company, the UltraFan will contribute to redefining sustainable air travel for decades to come. The 140-inch fan on the UltraFan demonstrator engine, which is currently being assembled, is the largest in the industry, 3.5 meters. When the UltraFan-powered gearbox reached 87,000 horsepower, or 64 megawatts, a record for the aerospace industry, it also made history. Chris Carlton, Rolls President Royce's for Civil Aerospace, stated, UF001, our first engine demonstrator, is coming together, and I can't wait to see it constructed and ready for testing. It is being released at a time when the world is searching for more environmentally friendly travel options in response to COVID-19, and it makes me and my team very proud to be part of the solution. A new family of UltraFan engines is expected to enter service around 2030, and the company claims that its new product will hasten the transition to sustainable aviation fuel. The initial test of the UltraFan will be conducted at 100% SAF. Current regulations allow a maximum 50-50 mixture of jet fuel and SAF in aircraft engines, but airlines use less than 1% SAF in their operations. The UltraFan will consume 25% less fuel than the first-generation Trent engines. Its manufacturer has stated that its scalable variants will eventually be available for narrow and wide-body aircrafts. Have you ever heard of any of these airplanes in the past? Leave your thoughts and questions in the comment section below. Thanks for watching today's video, and we'll see you in our next video.